Hi there. So back to growth and decay again. So last time we looked at compound interest. This time, once we've done a starter, we're going to start looking at depreciation. And that's the decay bit where things repeatedly get reduced by the same percentage. Okay, but first of all, let's have a look at what we did kind of last time in a way. There's a straightforward question for you to have a go at. And this one's ever so slightly different, but I'm sure you'll be great at it. Just get stuck in and have a go. Press pause now, have a go at these two questions, try and work out the compound interest, and unpause when you're done. Okay, so we've unpaused. Right, first of all, a bank gives compound interest. Now we know what that means. That means we're going to have to go back to our formula here where we do the original amount times by our multiplier and put it to the power of how many repetitions there are. In this case, years, so be to the power of 6. The first thing I'd say is probably our multiplier, isn't it? Now, if we're doing a 4.5% interest rate, now that means things are getting bigger. So we start with the 100% and we add on the 4.5%, and that will mean we have 104.5%. Okay, at the end of it. Now that's no use to us. We want it as a multiplier, really. So we change it into a decimal where we divide it by 100. Remember, we had this, let's this thing up here. If you want to go from a percentage to a decimal, divide by 100. That means it's 2 places smaller. Same digits, just 2 places smaller. So it's 1.045. That's our multiplier, so let's go back to our formula, this thing up here, that Dewberry. Right, 4,000 is our original amount, times by our multiplier of 1.045. That will increase it by 4.5%, but I want to do it for 6 years. That's 6 repetitions, so I put the power of 6. Okay, and then we put it in our calculator, 4,000 times by 1.045 to the power of 6. Is, and we're going to put it to the nearest whole pence. Firstly, the pounds. Oops, that's not a pound sign, is it? £5,209 and 4 pence. Right, well done if you got that one. And then this one, right? A bank gives compound interest at a rate of 3% per year. If you invested 3,500, how many years would it be before you have over 4,050, and I think that's supposed to be £4,050, isn't it? Right, okay, well, so we can't quite use our formula here, but we're going to do kind of a similar thing. All right, let's have a look. 3%. Well, first of all, it's interest, so things are getting larger all the time, and in this case by 3%. So let's work out what our multiplier would be. So we'll do 100%, so it always starts with 100, and then add 3%, so 103%. Change it into a decimal by dividing by 100, so 1.03. Okay, so if I was increasing this, I would do 3,500, and I'd times it by 1.03, and I put the power here of however many years I want to do it. Problem is, I want to find out how many years it's going to be until we have over £4,050. Now, here's what I'm going to do. Listen carefully. I am going to type in 3,500 and then I'm going to times it by 1.03 and that will increase it by 3%. Okay, so I've got £3,605. That's my, after 1 year, I've got 3,605. And then I'm going to do, again, I'm going to press answer, press the ANS button, that will use my last answer, and times that by 1.03, and it will increase that by 3%. So after 2 years, I have £3,713 and 15p. And what you do is you keep doing that, keep timesing it by 1.03 until, I'm just going to put this here, until you get a number which is over the target of 4,050. Still not there. After 4 years, we got £3,939, 28 pence. Now just keep doing it. Just keep timesing it by 1.03 until, haha, here we go, £4,057 and 46 pence to the nearest pence. And that is after how many years? 1, 2, 3, 4. That was 5 years. And that's what you do. So you just keep repeatedly timesing it by the multiplier until it's over the target, and then just remember how many times you've done it. That's why I kept writing out how much I had each time, so I knew how many times I'd done it. Yep. So sometimes they come up, just keep timesing it by the multiplier until you get to your target. But this time we're not going to look at interest, we're going to look at depreciation. Okay, we're going to decrease by a percentage. Now, depreciation is the sort of thing, well, I'm sorry, let's put a, oh no, we'll come to that in a minute. It's the sort of thing where, say, you've got a value of something, say a car. A car's a classic example. When you buy a car, it costs a lot of money, and it instantly loses a lot of money as soon as you bought it. And every year it loses a percentage of its value, and it just keeps losing that percentage every year. The car's worth less and less and less, until a very long time ahead when it might become a classic, but usually most cars have been scrapped by then. But let's think about this. Let's start with this bit. This is using a multiplier to decrease by a percentage. So, for example, decrease, so that means make smaller, 540 by 5%. And I'm going to use a multiplier for this because, as we found out last time, multipliers will be really useful for the repeated percentage change. Now, it starts off exactly the same as before. You still start with 100% because that's all of my money. 100% of 540 is 540, right? Now I'm decreasing. That's the important bit. So this is really the only difference here. This is going to be a whole long video with only really one difference. We take away. So instead of adding the 5%, I take the 5% away. So when I've taken my 5% off, I will be left with 95% of the original value. Again, turn it into a decimal. Remember, divide by 100. So 0.95 because it becomes 2 places smaller. This is my multiplier. And so if I take my figure of 540 and I times it by 0.95, it will reduce it by 5%. Easy, yeah? And I'll type it in my calculator, and the answer is 513. But for the minute, the multiplier is the really important thing I want. You know how to multiply stuff. It's getting the multiplier in the first place. Okay, again, so another decrease, this time by 12%. So start with your 100%. And we're going to decrease by 12%, so we'll take it off. And 100 take away 12 leaves 88, so 88%. And then turn it into that magic multiplier by dividing by 100. Turn it into a decimal, 0.88. And that's the magic reducing multiplier. It will reduce anything by 12% if you just times by it. So times by the multiplier. 3,100 times by 0.88 is 2728. 2,728. Magic, huh? And last one, let's decrease this number by 38%. Well, first of all, start with your 100%. Take off the percentage you're reducing by. We're reducing by 38, which leaves 62% left over. Turn it into a multiplier, which is 0.62. It's just 2 places smaller. And I can reduce anything by 38% by timesing it by 0.62. So let's use it here to reduce this by 38%. 850 times by 0.62 equals 527. Okay, now it's the multipliers that I'm really interested here. Oops, no, I don't want subtitles, go away. What I want is a red pen. There we go. So that's my multiplier for reducing by 5%. That's my multiplier for reducing by 12%. And this is my multiplier for reducing by 38%. Those are the magic things that I want you to find in this next task. Okay, we did one like this last time. I want you to find the multiplier used to calculate these percentage decreases, right? So you're going to have some questions there. And I don't want you to decrease anything because there's nothing to decrease. I just want you to find the multiplier in each case. So for example, if I was reducing by 24%, I would start with 100%. I would take off the percentage I want. And then I would be left with 76% in this case. And turn it into a decimal by dividing by 100, which is 0.76. 0.76. All right, that's the sort of thing that we're talking about. So press pause on the computer. No, not computer. I mean, whatever you're using. Press pause on the video. Find those multipliers, please, and then unpause when you're done. Okay, we have unpause. Now, I could have in the meantime changed color, but I didn't. Okay, a decrease of 26%. I'll do the first one and probably the last one. Otherwise, I'll just give you the answers. But 100%, take off 26% because we are decreasing, leaves 0, no, not 0. 100 take away 26 leaves 74. 74%, turn it into a multiplier by turning it into a decimal, 0.74. That's the first one. Okay, get the idea? So when you did this one, the multiplier you're after here would have been 0.92. Decrease by 50%, well, you'll be left with 50%. So either 0.5 or 0.50, either is fine. Decrease by 2.5%, okay, that would be 0.975. Okay, hope you got that one. And lastly, decrease by 150%. Well, that would be really quite a big decrease. That's a silly one, really. You're unlikely to get this one because you'd be in negatives here. But whatever, we'll do it. If you're asked to do it, we'll do it. Let's take off 150%. And what we're left with is negative 50%. Let's turn that into a decimal by dividing by 100, which is negative 0.5. Yep, okay. Oops. Oh, blimey, my calculator's gone a bit weird. Bear with me. Yep. Okay, and so that would be the multiplier. It's unlikely you would get that question, but you know, if it did, I suppose you have to be able to work it out. So there you go. Right, next. Let's have a look at this. What about actually using it for a question? So here we go. This is a classic kind of depreciation. Can't even speak. Depreciation question. A car costs 24,000 new. If the car loses 12% of its worth every year, how much will it be worth after 4 years? Well, let's find out. Well, first of all, let's start with that multiplier. 12%. Start with 100% and take off that 12% because we're reducing its cost. It's losing its value, so it's going down by 12%. And I'm left with 88%. Yep. Turn it into a multiplier. We know how to do this by now. So divide it by 100 and you've got 0.88. That's my multiplier. So let's use our formula up here for the repeated percentage change. Let's do our original amount of the car. Let's times it by 0.88 because that will reduce it by 12%. But I've got 4 years worth here. 4 years worth, so it's to the power of 4. Okay, let's see what answer that gives. I'll rewrite it on the bottom line so it's got a bit more space. And just put it in the calculator. Times by 0.88 to the power of 4. And it will be 14,000, well, this is pounds obviously, 14,392 pounds, and to the nearest pence, because it says 688, so that rounds up to 689 pence. Okay, it loses a lot of its value in the first 4 years there. Okay, right, let's try another one. A laptop costs £650 new. If the laptop depreciates, so the cost goes down, or its worth goes down, at a rate of 8% per year, how much will it be worth after 3 years? Again, we're up to our formula here. Let's figure out the multiplier first. Always start with 100% and take off the percentage we're losing. We're left with 92% after each year. So let's divide it by 100 and turn it into a decimal. And that is our magic multiplier. So £650 is my original cost, times by my multiplier, to the power of however many repetitions or years, however many times we're using it. And we're doing it three years worth here, 3 lots of the 8%, 8% each year rather. Let's put it in a calculator. 650 times by 0.92. Press that little button so that you can put the power in. If you're not sure where to put the power, that's a good point actually. You can get there from, usually on the calculator, the button looks something like an X, usually with a little blank square or an open square up there, or sometimes it's like an up arrow, but like Star Trek, I suppose. Then that also works as the power of. Okay. And oh, I just just deleted my calculation. That's very annoying. 0.92 to the power of 3 is, to the nearest pence, £506, and it says 1472, so it rounds up to 1.5, so 15 pence. Okay, so find your multiplier and then use the formula. 2 questions for you to do then. So it's your turn. Get your calculator out and press pause on the video and unpause when you have done the 2 questions. Please do have a go at these questions. It's really important that you do the exercises. Otherwise, it's just me talking to myself, which is a waste of time. Okay, right, so off you go and then unpause when you're done. We've unpaused, so let's have a look at what's going on here. Okay, a car costs £7,500 and it depreciates in value each year by 7%. What's the value after 2 years? Okay, fair enough. Let's find our multiplier first of all. So 100% take away 7% leaves 93%. Turn it into a decimal. You know how to do this. 0.93. Cool. Then use the formula. Original value 7,500. The multiplier to reduce it by 7% is 0.93. How many years? 2 years. So we'll do it twice. The power of 2. Let's go. 7,500 times by 0.93 to the power of 2 is, did you get this right? £6,486 and 75 pence. Hey, good. Good for you. Well done. An Xbox One S costs £400 new. If the Xbox depreciates at a rate of 15% per year, how much will it be worth after 4 years? Probably not a lot. Let's see. Okay, we're reducing by 15% because it's depreciating. So let's work out the multiplier. 100, we're reducing by 15%. And when I've done that, I will be left with 85%. 100 take away 15 is 85. Turn it into a decimal. Divide by 100. 0.85. Okay, let's use the formula. Original cost, £400. Multiplier to reduce by the percentage, 0.85. How many years? 4 years, so to the power of 4. And let's chuck it in the calculator. 400 times by 0.85 to the power of 4 is £208, and to the nearest pence, 80. 80 pence. Yeah, it loses a lot of value in that case. Right, let's try 2 more. No, not 2 more. Well, it's 1 question with 2 bits to it. Okay, it's about an iceberg. I'm not going to talk too much about this one. I just want you to give it a go. Try and do both bits, please. Think about what happened in the starter, the second part of the starter for part B down here, and then see if you can figure it out. Okay? Right, off you go. Unpause when you're done. We've unpaused. Now, if you weren't sure what this meant significant figures. I was wondering if you remember. You might have rounded to decimal places, but it should be significant figures. Okay, I'll show you what that means in a minute. Now, the iceberg moves into warmer water. This is big iceberg, and it decreases by a certain percentage each day. That warm water is melting the ice. What will the iceberg weigh after 3 days in the warmer water? Well, it's losing 25%. So let's do that. Let's lose 25%. And I'm left with 75% once we've taken that 25% off. Turn it into a decimal by dividing by 100. There's our multiplier, 0.75. That will reduce it by 25% each time. And then use our formula, 84,000 times by our multiplier. That reduces it by 15%. But I want to do 3 days. Now remember, it says years up here, but we talk a lot about repetitions, didn't we? This is really the number of repetitions. If it's losing 25% each day, I'm doing 3 days. There are 3 repetitions. Okay, I hope you figured that one out. 84,000 times by 0.75 to the power of 3, because it's happening over 3 days. We are left with 35437.5 tons. Now it said to round it, let's just change colour, round it to two significant figures. Let's see if you remember this. Now the first significant figure is the highest value digit, keeping in mind place value. So place value, that one there, that 3 is the highest value digit because it's in the 10,000s column. It's worth 30,000. The one next to it's only worth 5,000. Anyway, so the highest value digit is the first significant figure, so that's that. The second one is the one next to it. So we're rounding to this level, right? So look at the next number across. Do I round up my 5 or leave it alone? Well, I leave it alone because it's a 4, it's not 5 or above, so I just leave it as a 5. But I've got to keep the place value. I can't suddenly change 35,400 and something into 35. It's got to be 35,000, right? So to two significant figures, it's that. So well done if you got the calculation. Another well done if you managed to get the answer. And then if you actually did the rounding to two significant figures, awesome work. How many days will it be until it weighs less than 10,000 tons? So this is just like that question at the beginning where it's how many years will it be until something costs more than a certain amount or worth more than a certain amount. Here, I'm going to start with 8,400 and I'm going to times it by 0.75 and I'm going to see what my answer is in my calculator. 0.75 and after 1 day there's 63,000 left. Now I'm going to times that by the 0.75 again and times that new answer and I've got 47,250 and I'm going to times it again. So how many times have I times it so far? It's 0.75 times by 0.75 and that gets us there. So that was 3 days. Let's do it again. 4 days. Oh, still 26,000. Let's do it again. Oh, still loads. 0.75. Still 19,900. And you just keep timesing it by this until you get down to the figure that you want. And I keep doing it until I get down to the figure that I want. Now I'm just going to double check. Let's have a quick double check on this. Let's go back to my original amount and then times it by 0.75. That's 1, 2, 3, 4, 5, 6, 7, 8 times. Did I write enough down here? 1, 2, 3, 4, 5, 6, 7, 8. Oh, I did too many. There's 9. All right. It is 8 days. And that's the basic way you work with that. When you work out what the calculation is, and you just keep doing it in your calculator, keep timesing it by the answer by that multiplier, and just see how many times you have to do it until you reach your target. And in this case, it's 8 days, at which point it's only 8,409 tons. Much smaller than it originally was. All right, okay. Depreciation rate. Now this is my last example and I'm not going to get you to do one like this. I'm just going to kind of show you in case you get a question like this. It very occasionally comes up. It's a tricky question, but I thought I'd talk you through it just so you've had the input. So I've told you how to do it and you can always refer to it again if you need to. I thought I'd just show you just in case. Right, a car costs £12,000. After 3 years, the car is worth this, 10,616. What was the depreciation rate? What is the percentage rate that was used to reduce it? Well, let's think about our formula. If I was using my formula, I'd start with my original amount. I would then times it by my multiplier. Now, I don't know what the multiplier is, but so we'll put question mark. And it's to the power of 3 years. So I would put that to the power of 3. And when I do that, apparently, I get 10,616.83. What I'm going to do is rearrange this to try and solve it, to try and find this question mark, this missing number. First thing I'm going to do, instead of timesing by 12,000, I'm going to divide by the 12,000. I'm going to do that on both sides of my calculation. So now this side, obviously that's going to cancel out the divide. So we've got our rate to the power of 3. But this side I've got my 10,616.83 divided by my original amount. Now this is tricky. How do I do this? How do I do this? Well, if I had something squared, let's say I had x squared, and that equaled something, x squared equals 4. If I wanted to find out what x was, I would have to do the opposite. I'd have to square root the 4. That would tell me it's 2. Now, if I had something that's cubed, like we have here, let's say I've got 8, what I need to do is what we call the cube root. And if you look on your calculator, press Shift and the root button, square root button, you get a cube root. And that will find the cube root of my number. So that's what I'm going to do. I'm going to find the cube root. So to undo that cubing, you do the cube root of the reduced figure divided by the original cost. Okay, so all I've done is rearrange it. And when I do that on my calculator, let's see what I get. Let's do, so cube root of £10,616.83 divided by the 12,000. You can try it on your calculator too. And that equals 0.95, and it's 9 recurring. Now that is roughly equal to, it's pretty much bang on, 0.96. Because we want to do it to the nearest percent, really. Now, what percentage is that reduction? What have I taken? If I start with my 100%, what have I taken away to get to what is 96%? Because that's the same as 96%, isn't it? What have I taken away? And the answer is 4%. Now, as I say, that is a tricky, tricky question. But just in case it comes up, we've been through it. Okay, but give it a go, because you never know, you might get it right. But let's focus on the main thing here: finding the multiplier for a depreciation and knowing how to use the formula. If you can do that, it'd be brilliant. That's exactly what I want. If you can do a question like this, well, happy days. All right. Next, I believe you've got the My Maths task that goes with this. So have a go at that. Remember, just one little thing: when it says depreciated value, that means the value after, or the reduction of 13 years. Depreciation is actually how much it has reduced by. How much it has reduced by goes in that box there. The actual reduced cost is there, but how much has it gone down by would be in there. All right. Okay. Good luck.